A cam with a minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of wall rod motion described below. First one, to rise the wall through 50 mm during 120-degree rotation of the cam. Second one, to keep the wall fully raised through next 30 degree, to lower the wall during next 60 degree, and to keep the wall closed during the rest of the revolution, that is 150 degree. The diameter of the roller is 20 mm. Draw the profile of the cam when A. The line of stroke of the wall rod passes through the axis of the camshaft, and B. The line of stroke is offset 15 mm from the axis of the camshaft. The displacement of the wall while being raised and lowered is to take place with simple harmonic motion. Data given are listed over here. The outstroke 120 degree, outstroke dwell period 30 degree, return stroke 60 degree, then return stroke dwell period 150 degree, stroke, the total lift of the wall, that is nothing but stroke, is equal to 50 mm, minimum radius of the cam 25 mm, diameter of the roller 20 mm, follower, the given follower is a roller follower, and roller follower moving with simple harmonic motion during both outstroke and return stroke. So first we will construct a displacement diagram for given follower motion. So here the follower moving with simple harmonic motion. So we know in displacement diagram, x-axis represent one rotation of the cam and y-axis represent the corresponding displacement of the follower. To represent one rotation of the cam on x-axis, so we have to choose a suitable scale. Let on x-axis, the scale on x-axis 1 centimeter is equal to 20 degree of cam rotation. If you draw 1 centimeter line on x-axis, it represents a cam rotation of 20 degree. So one rotation, you convert the one rotation of the cam, that is 360 degree, into linear distance by using scale. So 360 divided by 20 is equal to 18 centimeter. Draw 18 centimeter line. So it represents one rotation of the cam. Now draw 50 millimeter line on y-axis. So it represents lift or stroke of the follower. Complete the rectangle. Now mark outstroke, dwell period, return stroke, and a return stroke dwell period on x-axis. So in this problem, outstroke is equal to 20 degree. You convert this 120 degree into linear distance by using scale. 120 divided by 20 is equal to 6 centimeter. So from the starting point, measure 6 centimeter. So this line segment AS represent the outstroke. That is theta naught is equal to 120 degree. Dwell period. So in this problem, the dwell period is 30 degree So convert this 30 degree into linear distance. 30 divided by 20 is equal to 1.5 centimeter. Now from point S, you measure 1.5 centimeter. 1.5 centimeter from S. So this line segment SR represent the dwell period. Now mark the return stroke. So in this problem, return stroke, that is theta r is equal to 60 degree. 60 divided by 20, so is equal to 3 centimeter. From R, you measure 3 centimeter and mark the return stroke. Then the line segment, this line segment represent the dwell period. Since the follower moving with simple harmonic motion, so take this stroke as diameter and draw the semicircle. Divide the semicircle into any number of even equal parts. So here I am dividing the semicircle into 6 equal parts, that is 180 degree divided by 6 is equal to 30 degree. Use the protractor to divide the semicircle into 6 equal parts. So each division is equal to 30 degree and mark the division point as A, B, C, D, E, F and connect the division points with the center of the semicircle. Now divide this outstroke and return stroke into 6 equal parts. So here I am divided the semicircle into 6 equal parts. Divide this outstroke and return stroke into same number of even equal parts. So divide this outstroke into 6 equal parts and name the division points as 1, 2, 3, 4, 5, 6 and draw vertical line from these division points. Now divide the return stroke into 6 equal parts and draw the vertical line. Now from the point A, draw the horizontal line. So this horizontal line intersect the vertical line from point 1 and you mark this intersection point as B. Now draw the horizontal line from B. This horizontal line intersect the vertical line from point 2. You mark the intersection point and name this intersection point as C. Similarly, from C and mark the intersection point here and name the intersection point as D. Obtain the point E. Now from point E, draw the horizontal line. It intersects the vertical line from 5. You mark the intersection point and name the intersection point as F. Now the horizontal line from F, it intersects the vertical line from 6 here and you mark the intersection point and name the intersection point as Z. Similarly, obtain the remaining points on the return stroke and name the intersection point as H, J, K, L, M, N, P. Now connect all the intersection point with a smooth curve and this curve represent the displacement diagram when the follower is moving with simple harmonic motion. Now we will see the construction of the cam profile when line of stroke of the valve rod passes through the axis of the camshaft. ಸೊ ಇಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಫಾಲೋಯರು ರೋಲರ್ ಫಾಲೋವರ್ ಆಗಿರೋದ್ರಿಂದ ಸೊ ಫಸ್ಟ್ ನಾವು ಪ್ರೈಮ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಸೊ ಪ್ರೈಮ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನನಗೆ ಎರಡು ಇನ್ಫಾರ್ಮೇಷನ್ಸ್ ಬೇಕಾಗ್ತದೆ. ವಿ ನೀಡ್ ಟೂ ಇನ್ಫಾರ್ಮೇಷನ್ಸ್. ದ ಫಸ್ಟ್ ಒನ್, ಬೇಸ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ and roller radius. So calculate the prime circle radius is equal to base circle radius plus roller radius. So base circle radius is 25 and roller radius is 10. 25 plus 10 is equal to 35 millimeter. Knife edge ಬಂದಾಗ ಈ ಪ್ರೈಮ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ ಅವಶ್ಯಕತೆ ಬರೋದಿಲ್ಲ. ಬಟ್ ರೋಲರ್ ಫಾಲೋಯರ್ ಕೊಟ್ಟಾಗ ಸೊ ಪ್ರೈಮ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ನ ನಾವು ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕಾಗ್ತದೆ. ಆಲ್ರೆಡಿ ನಾವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ನ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ್ದೇವೆ. ಸೊ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಫಾಲೋಯರ್ ಮೋಷನ್ಸ್ಗೆ ನಾವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ನ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದ್ದೇವೆ. ನಂತರ ಕ್ಯಾಮ್ ಪ್ರೊಫೈಲ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಸೊ ಈಗ ಪ್ರಾರಂಭ ಮಾಡೋಣ. ಸೊ ಫಸ್ಟು ಪ್ರೈಮ್ ಸರ್ಕಲ್ ರೇಡಿಯಸ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ನಾವು ವಿತ್ ಓ ಎಸ್ ಸೆಂಟರ್ radius is equal to 25 millimeter. Draw the base circle. Again with OS center, radius is equal to 35 millimeter. Draw prime circle. So here line of stroke of the wall rod, that is the follower, passes through the axis of the camshaft. Now mark the point A, that is initial position of the roller, where this vertical axis intersect the prime circle. So this point A represent the initial position of the roller center. Now with A as center and radius is equal to 10 millimeter, draw the starting point of roller follower. Now from line OA, measure 120 degree. This 120 degree represent outstroke. Measure 30 degree. So this 30 degree represent the dwell period. Measure 60 degree. Next you measure 60 degree. So this 60 degree represent the return stroke. Then remaining 150 degree, it represent the dwell period. Now you divide outstroke and return stroke into 6 equal parts. So ಯಾಕೆ 6 equal parts ಮಾಡ್ತಾ ಇದೀವಿ? So displacement diagram ನಲ್ಲಿ this outstroke and return stroke, they are divided into 6 equal parts, right? So divide 120 degree into 6 equal parts and name the division points as 1, 2, 3, 4, 5, 6. Similarly divide the return stroke into 6 equal parts and name the division points as 1 dash, O1 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. So displacement diagram ಸಹ ಇದೇ notation ನಾನು ಯೂಸ್ ಮಾಡಿದ್ದೇನೆ. ಹಾಗಾಗಿ ಇಲ್ಲೂ ಸಹ ಅದೇ notations ನಾನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. So after dividing this outstroke and return stroke into 6 equal parts, connect the point 1 with the center O and extend the line behind the base circle. ಈ ಪಾಯಿಂಟ್ 1 ಅನ್ನ ರೋಲರ್ ಸೆಂಟರ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಆ ಲೈನ್ ಅನ್ನು ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಪ್ರೈಮ್ ಸರ್ಕಲ್ ಇಂದ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Similarly connect the point 2 with the center and extend the line behind the prime circle. Now connect the point 3, point 4, point 5, point 6, then O1 dash, 1 dash, 2 dash, connect 3 1 dash with the center and extend the line behind the prime circle, 4 dash, 5 dash, and 6 dash. Okay. We know while constructing the cam profile, we follow the principle of kinematic inversion. So according to principle of kinematic inversion, we assume cam is stationary and the follower is rotating around the cam profile. So ಈ ಕೇಸಿಗೆ ಬಂದಾಗ this outstroke 120 degrees divided into 6 equal parts. So each division represent 20 degree of cam rotation. So ಈಗ ಫಾಲೋಯರ್ ನಾನು ಏನು ಮಾಡ್ತೀನಿ 20 ಡಿಗ್ರಿ ಹೀಗೆ ರೋಟೇಟ್ ಮಾಡ್ತೀನಿ. ಅಸ್ಯೂಮ್ ದ ಫಾಲೋಯರ್ ಇಸ್ rotated through 20 ಡಿಗ್ರಿ. ಸೊ ಯಾವಾಗ ಫಾಲೋಯರು ಕ್ಯಾಮ್ ಪ್ರೊಫೈಲ್ ಮೇಲೆ 20 ಡಿಗ್ರಿ ಹೀಗೆ ರೊಟೇಟ್ ಆಗ್ತದೋ ಆವಾಗ ರೋಲರ್ ಸೆಂಟರ್ ಏನಾಗ್ತದೆ, ಇಟ್ ಲಿಫ್ಟೆಡ್ ಫ್ರಮ್ ದ ಪ್ರೈಮ್ ಸರ್ಕಲ್ ಥ್ರೂ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ರೈಸ್ ಆಗ್ತದೆ. ಸೊ ಎಷ್ಟು ರೈಸ್ ಆಗ್ತದೆ ಅಂತಕ್ಕಂಥ ಇನ್ಫಾರ್ಮೇಶನ್ ನಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಸಿಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ದಿಸ್ ಔಟ್ ಸ್ಟ್ರೋಕ್ ಇಸ್ ಡಿವೈಡ್ ಇಂಟು 6 equal parts. So each division represent 20 degree of cam rotation, right? This A1 represent 20 degree of cam rotation, and this vertical line 1B represent the corresponding displacement of the follower. So you measure 1B ನ measure ಮಾಡಿ ಸೊ ಈ 20 ಡಿಗ್ರಿ ಲೈನ್ ಮೇಲೆ ಅದನ್ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ 1B, ರೈಟ್. ಸೊ ಇಫ್ ರೋಲರ್ ಫಾಲೋಯರ್ 40 ಡಿಗ್ರಿ ರೊಟೇಟ್ ಆಯ್ತು ಅಂತ ಅಂದ್ರೆ ಅಗೈನ್ ದಿಸ್ ರೋಲರ್ ಸೆಂಟರ್ ಲಿಫ್ಟೆಡ್ ಫ್ರಮ್ ದಿ ಪ್ರೈಮ್ ಸರ್ಕಲ್, ರೈಟ್. ಸೊ ಲಿಫ್ಟ್ ಆಗ್ತದೆ. ಸೊ ಈ ಇನ್ಫಾರ್ಮೇಶನ್ ನನಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ ಸಿಗ್ತಾ ಇದೆ. ಸಿ ದಿಸ್ ಸೆಕೆಂಡ್ division, that is A2 represent 40 degree of cam rotation, and this vertical line 2C represent the corresponding displacement of the follower, right? So ಆ 2C ನ measure ಮಾಡಿ ಅದನ್ನ 40 ಡಿಗ್ರಿ ಲೈನ್ ಮೇಲೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹಾಗೇನೆ ಸೊ 6 ಡಿಗ್ರಿಗೆ ಇಲ್ಲಿ 3D ನ ಮೆಜರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಲ್ಲಿ A3 ಏನಿದೆ ಇಟ್ ರೆಪ್ರೆಸೆಂಟ್ 60 ಡಿಗ್ರಿ ಆಫ್ ಕ್ಯಾಮ್ ರೊಟೇಷನ್ and 3D represent the corresponding displacement of the roller center, right? So 3D ನ measure ಮಾಡಿ 60 degree line ಮೇಲೆ ಅದನ್ನು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ಸಿಮಿಲರ್ಲಿ 4E, 5F, ಸೊ 6G. ಸೊ ಎಲ್ಲ ಡಿಸ್ಟೆನ್ಸ್ಗಳನ್ನ ನಾನು ಈ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಯಾಗ್ರಾಮ್ ಇಂದ ಮೆಜರ್ ಮಾಡಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಲೈನ್ ಮೇಲೆ ಅದನ್ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ರಿಟರ್ನ್ ಸ್ಟ್ರೋಕ್ಗೂ ಫಾಲೋ ಆಗ್ತದೆ. ಸೊ O'(H), 1'J, 2'K ಈ ಎಲ್ಲ ಡಿಸ್ಟೆನ್ಸ್ಗಳನ್ನ ಮೆಜರ್ ಮಾಡಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಲೈನ್ ಮೇಲೆ ಅದನ್ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಈ BCDEFG ಇದೆಲ್ಲ ಏನ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ರೋಲರ್ ಸೆಂಟರ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಈಗೇನ್ ಮಾಡ್ತೀನಿ, ರೋಲರ್ ರೇಡಿಯಸ್ 10 ಮಿಲಿಮೀಟರ್ ಇರೋದ್ರಿಂದ 10 ಮಿಲಿಮೀಟರ್ ರೇಡಿಯಸ್ ಇಟ್ಕೊಂಡು ಸೊ BCDEFG ಮತ್ತೆ HJKLMNP ದೇ ಆರ್ ದ ಸೆಂಟರ್. as center you draw a different position of the roller. So 20 degree rotate ಆಯ್ತು ಅಂದ್ರೆ this is the roller position, 40 ಡಿಗ್ರಿಗೆ this is the roller position, right? ಹಾಗೆ 60, 80, 100 ಮತ್ತೆ 120 ಡಿಗ್ರಿಗೆ ಸೊ ರೋಲರ್ ಪೊಸಿಷನ್ ನಾನು ಡ್ರಾ ಮಾಡಿದ್ದೀನಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೋದು, ಯು ಕನೆಕ್ಟ್ ಆಲ್ ದ ಬಾಟಮ್ ಪಾಯಿಂಟ್ಸ್ ಆಫ್ ದಿ ರೋಲರ್ ವಿತ್ ಎ ಸ್ಮೂತ್ ಕರ್ವ್. ಸೊ ನೀವು ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ, ವಿ ವಿಲ್ ಗೆಟ್ ದಿ ಕ್ಯಾಮ್ ಪ್ರೊಫೈಲ್ ಸಿಗ್ತಾ ಇದೆ ನಮಗೆ. ಸೊ ಎರಡನೇ ಕೇಸ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. when the line of stroke is offset 15 millimeter from the axis of the camshaft. So previous case ನೋಡಿದಾಗ line of stroke is passing through the center of the camshaft. So ಈ ಕೇಸಲ್ಲಿ the line of stroke is offset 15 millimeter from the axis of the camshaft. So prime circle radius ನಾವು calculate ಮಾಡಿದೀವಿ previous slide ಅಲ್ಲಿ. So base circle radius is 25, roller radius is 10, the prime circle radius is 35, and offset is equal to 15 millimeter. Now with OS center, radius is equal to 25 millimeter, draw the base circle. Again with OS center, radius is equal to 35 millimeter, draw the prime circle. With OS center, radius is equal to 15 millimeter, that is offset, draw the offset circle. Since line of stroke is offset by 15 millimeter, draw line of stroke of the follower 15 millimeter away from the cam center. Mark the point A where this vertical axis intersect the prime circle. Now A as center and radius is equal to 10 millimeter, draw the roller. Connect OA. Now from line OA measure 120 degree. So this 120 degree represent the outstroke. Now measure 30 degree. This 30 degree represent the dwell period. Mark 60 degree. This 60 degree represent the return stroke. Remaining 150 degree, it represent the dwell period. Now divide this outstroke and return stroke into 6 equal parts and name the division points as 1, 2, 3, 4, 5, 6. Similarly, divide the return stroke into 6 equal parts. Name the division points. After dividing this outstroke and return stroke, now from point 1, draw tangent to this offset circle and extend the tangent behind the prime circle. From point 1, draw tangent to offset circle and extend behind the prime circle. Similarly, draw tangent from 2 to this offset circle and extend the line behind the prime circle. Now from point 3, point 4, point 5, point 6, then from O1 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. You draw the tangents. Now, according to the principle of kinematic inversion, so we assume cam is stationary and follower rotating in anti-clockwise direction. So when the follower rotates through 20 degree, so here 120 degree is divided into 6 equal parts. So each division represent 20 degree. When it rotates through, when the roller follower rotates through 20 degree, the center of the roller lifted from the prime circle through certain distance. So you will get this information from the displacement diagram. You measure this distance. So when cam rotates to 20 degree, this is the displacement of the follower. When it rotates through 40 degree, and this is the corresponding displacement of the follower, measure this distance and transfer to the corresponding line and name the division points. ಅಲ್ಲಿ ಯಾವ ನೇಮ್ನ ಕೊಟ್ಟಿದ್ದೀರೋ ಅದೇ ನೇಮ್ನ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಹಾಗೇನೆ ರಿಟರ್ನ್ ಸ್ಟ್ರೋಕಲ್ಲೂ ಎಲ್ಲ ಡಿಸ್ಟೆನ್ಸ್ನ ಮೆಷರ್ ಮಾಡಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಲೈನ್ಗೆ ಅದನ್ನು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಎಲ್ಲ ರೋಲರ್ ಸೆಂಟರ್ ಸಿಕ್ಕಿದ ಮೇಲೆ, ಸೊ ವಿತ್ 10 millimeter as radius and center B, C, D, E, F, G, H, J, K, L, M, N ಮತ್ತೆ P. So you draw the circle. ಸೊ ಇದೆಲ್ಲ ಬೇರೆ ಬೇರೆ ಪೊಸಿಷನ್ ರೋಲರ್ ಪೊಸಿಷನ್ ತೋರಿಸುತ್ತೆ. ಅಂದರೆ 120 ಡಿಗ್ರಿ ರೊಟೇಟ್ ಆದಾಗ ದಿಸ್ ಇಸ್ ದ ರೋಲರ್ ಪೊಸಿಷನ್, 40 ಡಿಗ್ರಿ ರೊಟೇಟ್ ಆದಾಗ ದಿಸ್ ಇಸ್ ದಿ ರೋಲರ್ ಪೊಸಿಷನ್. ಇದು 60 ಡಿಗ್ರಿಗೆ, ಇದು 80, 100, 120 ಡಿಗ್ರಿಗೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಯು ಕನೆಕ್ಟ್ ಆಲ್ ದ ಬಾಟಮ್ ಆಫ್ ದಿ ಸರ್ಕಲ್ ಟು ಗೆಟ್ ದಿ ಕ್ಯಾಮ್ ಪ್ರೊಫೈಲ್. ಸೊ ಈ ಎಲ್ಲ ಸರ್ಕಲ್ ಬಾಟಮ್ನ ನೀವು ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಬಂದರೆ ನಮಗೆ ಕ್ಯಾಮ್ ಪ್ರೊಫೈಲ್ ಸಿಗ್ತದೆ. So this line, this curve represent the cam profile. Thank you.